Ever wondered what measurement and estimation mean in the world of physics? Let's dive right into it. Measurement is frankly a cornerstone of modern life. In the realm of physics, it's the process of determining the size, length, or amount of something by using specific instruments or devices. These tools are designed to quantify the item we're studying. Whether you're measuring the length of a table with a tape measure or the weight of an apple with a scale, you're using an instrument to obtain a precise value. This precision is crucial in physics, where accuracy can be the difference between a successful experiment and a failed one. But what about estimation? Estimation is a little less precise, but no less important. It's a method of approximating a value based on informed knowledge or experience. Let's say you're looking at an apple and you want to guess its weight. You might not have a scale handy, but based on your experience with apples, you could estimate that it weighs around a certain value. This estimation wouldn't be as precise as a measurement, but it would give you a ballpark figure. So, the key difference between measurement and estimation then is the precision. Measurement gives us precise values, using tools and instruments to quantify exactly what we're looking at. Estimation, on the other hand, gives us an approximate value based on our knowledge and experience. Think of measurement as a surgeon's scalpel, precise and accurate, while estimation is more like a chef's knife, versatile and flexible. They both have their roles, their advantages, and their limitations. In the world of physics, these concepts aren't just academic ideas, they're practical tools. They help us understand the world around us, from the smallest particles to the vastness of the universe. So, to sum it all up, measurement gives us precise values, while estimation provides us with approximate values. Both are integral parts of understanding and exploring our world. Now that we know what measurement and estimation are, let's explore how they differ. In the world of physics, measurement is a precise process that involves specific instruments like rulers, scales, and thermometers. It's all about getting an exact, objective value. On the other hand, estimation is a quicker, less precise method. It's based on our judgment and experience rather than on exact instruments. Imagine you're trying to guess how tall a tree is. You don't need a ruler for that, you make an educated guess based on what you already know about the average height of a tree. So, while measurement gives us precision, estimation gives us speed and practicality. Measurement is like using GPS to get to a destination, while estimation is like roughly plotting the route in your head. Both have their place, depending on the situation. While measurements are precise, estimations can sometimes be more practical in everyday life. Now, let's shift our focus to physical quantities. Picture this. A physical quantity is essentially a property of a phenomenon, body, or substance that can be quantified by measurement. It's like a language that enables us to describe the world around us in a more precise and scientific way. To make this concept a tad easier, let's break it down into two main categories: fundamental quantities and derived quantities. Fundamental quantities, also known as base quantities, are the building blocks of measurement. They form the foundation upon which all other measurements are based. The 7 fundamental quantities are length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. These are the core elements that we measure directly using specific instruments. Now imagine building a house. You have your bricks, which are your fundamental quantities. But a house is not made up of bricks alone, is it? You have windows, doors, and other elements that are constructed from these bricks. That's where derived quantities come in. Derived quantities are those that depend on or are derived from the fundamental quantities. They are like the windows and doors of our house. These include quantities like speed, which is derived from length and time, volume from the cube of length, and density, which is mass per unit volume. And of course, each of these quantities needs a specific instrument for its measurement. Length is measured using a ruler or tape measure, mass with a balance, and time with a clock. Speed, volume, and density, being derived quantities, are calculated using the measurements of the fundamental quantities. So, you see, physical quantities are all around us, influencing every aspect of our lives, from the speed of our cars to the volume of our coffee cups, and even the density of the air we breathe. Understanding these basic concepts in physics helps us comprehend the world around us in a more scientific way.